Now we can see the question number 31. Which of the following statement is not true for lyophobic salts? My dear students, here we can see the lyophobic salts. Lyophobic salts are those salts which are not solvated. Concept. What is the difference between the lyophobic and, my dear students, here lyophilic? You can see the in lyophobic particle size is bigger, and here you can see the in lyophilic particle size is smaller, and lyophobic, when lyophobic are positively charged, for example, we can take the positively charged on the surface of lyophobic. But here you can see no solvent layer is adsorbed by the lyophobic, but when you can see the positively charged is present on lyophilic. After this positive charge, which are adsorbed by this lyophilic, here you can see the solvated layer or water molecule layer is also adsorbed. This is the water molecule layer, water layer. So, my dear students, you can see here water layer is present on the surface of lyophilic, but this layer is not present in lyophobic. This is the difference, my dear students. So, lyophilic is more stable than lyophobic. Here you can see the size of lyophilic is greater. Number third, you can see the water layer here not present, and here this is present. My dear students, here stability is less stable than lyophilic. Stability of lyophilic is greater than lyophobic. Here I give you, my dear students, it is a difference, and by the difference you can see the lot of questions which are asked in NEET exams. So, I can give you concept and theory. So, you can solve the other questions also, my dear students, which are asked in NEET exams. Now, you can go the answer, that is B, because question is that not true. Yes, it is not true. Which of the following statement is not true? It can be easily solvated. So, my dear students, question number 31, and you can see the answer B, because it is not easily solvated, because water layer is not present on this surface of lyophobic. You can see here. So, it can be easily solvated. This statement is a wrong statement. Now, we can go to the question number 32. A salt has positively charged colloidal particles. Which of the following solution is required in lowest concentration for coagulation? Lowest concentration, my dear students, concept is that higher the charge, higher the opposite charge of an electrolyte, higher the opposite charge of electrolyte require the minimum concentration. Now, here you can see the +1 charge, here you can see the +2 charge, here you can see the +1 charge, and my dear students, here +1 charge, and here you can see negative charge 4 minus, -2, -1 and -1. So, my dear students, here if you have positively charged colloidal salt, so my dear students, you can think that which electrolyte get the lowest concentration? Obviously, in which charge is greater, more charge is present, opposite charge, it requires lowest concentration. So, my dear students, this B is the correct answer, because here maximum charge is present. So, require lowest concentration of electrolyte in which maximum opposite charge is present. Maximum opposite charge is present. So, my dear students, you can go the answer B. And this is the question, and according to this type of question, and you can solve, my dear students, new type of questions, because I am giving you concept, theory and tricks. Now, you can go to the question number 33. In which of the following states the particle size would be greater than 100 nanometer? My dear students, when greater the particle size means colloidal solution is not present. Here particle size of suspension is always greater than, because my dear students, what is the suspension? Another name of precipitate is also called suspension. Suspension, then you can get the colloidal solution, and colloidal solution, then you can get the, my dear student, that is the true solution. So, this is the concept, my dear students. You can get first of all suspension, then colloidal solution, then true solutions. So, you can go the answer A. Now, we can see here question number 34. Which of the following is not a colloid? Simply air is not a colloid. Why? Concept is already discussed, my dear students. Air is a mixture of gases. Mixture of gases. And my dear students, when you get the nitrogen and oxygen, particle size of nitrogen and oxygen is less than this 10 angstrom. So, this is not a colloidal form. Now, we can see the question number 35, my dear students. Purple of Cautious is, my dear students, it is a colloidal solution of gold. It is a colloidal solution of gold. When you can prepare the colloidal solution of gold, when you can place the rod of gold and electricity is generated, positive and negative charges are present, and this is the ice cold water. Ice cold water, then electric discharge is obviously, that is the 10,000 volt. Then, my dear students, this gold is converted to vapor form. Gold solid electrode is converted into vapor form, and when these vapors are condensed, then you can get the gold solid small particles, and so it is called gold colloidal solution, of gold. So, my dear students, here you can see you can prepare the gold solution, and this process is called, my dear students, Brady arc process. So, this is the theory, and this solution is called purple of Cautious. Now, we can go to the question number 36. Separation of colloidal particles from those of molecular dimensions with electricity. When separation is done, my dear students, we can already discuss this. This is called electrodialysis. Question number 36. Because in electrodialysis, we can separate the colloidal particles and this is the cations and anions. When you can place, this is the SPM, you can see this picture also, and we can place the electrode, this is negatively charged. Then, my dear students, here colloidal particles are present, but positive cations are come and attracts towards this electrode. So, my dear students, you can see this type of, this is the water, and this type of process is called electrodialysis. Here this is the electrodialysis. So, my dear students, I am giving you theory of this question, and also I am giving you, my dear students, theory of this question, and also I am giving you concept and tricks. So, you can solve the all other questions which are asked in NEET exams. Now, my dear students, we can go to the question number 37. Smoke is an example of, already discussed it. Smoke is an example of when this solid particle disperses in a gas and form a smoke. Already discussed this part. Now, we can see the question number 38. The Brownian movement is due to, my dear students, Brownian movement. You can see here what is the theory of Brownian movement. When, my dear students, this is the colloidal solution, and in this colloidal solution colloidal particles are present, and here you can see the particles of solvents. When these solvent particles are this attract, when this collide with this colloidal particle, it go to this side, and when these two particles are collide, this go to inside, and when these three solvent particles are collide with this colloidal particle, then it go in this direction. And my dear student, this is called zigzag motion, and this zigzag motion is called Brownian movement. It is called Brownian motion. So, Brownian motion is given by the colloidal particle. Why? Because its impact on the impact of molecules of dispersion medium, this is a dispersion medium on the colloidal particles. Now, my dear students, we can, this is a theory of Brownian motion. Now, we can see the question number 39. Which of the following is not a property of hydrophilic salts? My dear students, hydrophilic salts are those salts. What is the concept? Here we can see the concept. Hydrophilic salts means, hydro means water and philic means attracting. Those salts, my dear students, which are attract towards the water molecules are called hydrophilic salts. So, my dear students, hydrophilic salts are reversible salts, but here he want the not a property of hydrophilic salts. So, my dear students, you can see here in hydrophilic salts, surface viscosity is maximum, viscosity is greater than surface tension. So, my dear students, this property is also present in hydrophilic salts. So, you can go the answer C. Viscosity and surface tension nearly same as that of water, not at all. Viscosity is greater than water, but surface tension is less than water. So, you can go the answer C, question number 39. Here, my dear students, we can go to the question number 40. On adding few drops of dilute HCl to freshly precipitate ferric hydroxide, a red colored colloidal solution is obtained. The phenomenon is called. Here, my dear students, what is the concept and theory? Here you can see the freshly precipitate ferric hydroxide means FeOH whole thrice. It is a precipitate is formed. Small amount of an electrolytes are added, for example, HCl is act as electrolyte. When this electrolyte is added, my dear students, then this precipitate means ferric hydroxide absorb these electrolytes, ions, and my dear students, when these absorb the ions of H plus ions, then this is converted to positively charged colloidal particles. So, it is converted to colloidal solution. So, this is the process, my dear students, when precipitate is converted into colloidal solution by the addition of electrolyte. This is called, my dear students, peptidization. So, this process is called peptidization. My dear students, so question number 40 you can answer, you can get the answer A, because peptidization is present on answer A. Now, my dear students, this is the question number 41. Which of the following is a hydrophilic colloidal sol? My dear students, what are the hydrophilic and hydrophobic colloidal sol? We can see here concept. What is the concept of this question? All metal hydroxides, and sulfides, all metal hydroxide and sulfides are formed, all metal hydroxides and sulfides are formed hydrophobic sols. This is the concept, my dear students, number 1. Number 2, all organic compounds generally formed lyophilic sol. Here you can see that, for example, gelatin, it's an organic compound. Number 1, gelatin. Number 2, my dear students, starch. Number 3, gelatin is starch, gum. These are organic compounds and form a lyophilic. Here you can see question number 41. He asked the hydrophilic, lyophilic, or it is also named, another name of lyophilic is called hydrophilic. Another name of lyophilic is also called hydrophilic sol. So, you can see here all organic compounds generally formed lyophilic sol or hydrophilic sol. My dear students, in this question number 42, the stability of lyophilic colloids is due to, what is the concept of this question? Stability of lyo means liquid and philic means loving. Those solutions which are liquid loving are called lyophilic. So, my dear students, stability of lyophilic sols is due to the presence of a solvent layer. You can see here solvent layer is present on the lyophilic colloidal sol. So, my dear students, when solvent layer protect the lyophilic colloidal sol, so you can see here a layer of dispersion is the answer of question number 42. Answer is D. A layer of dispersion means water layer. Water is act as a dispersion medium. It's act as a dispersion medium. So, here my dear students, you can see the question number 42, answer is D. Now, we can see the question number 43. Tyndall effect is more pronounced in, my dear students, Tyndall effect, what is the concept? Tyndall effect is only shown by the colloidal sol in which particular size of colloidal particles is there. So, here you can see the size of hydrophobic or lyophilic colloidal sol is always then hydrophilic sols, because my dear students, here size of hydrophobic is always greater than hydrophilic. So, my dear students, when size is greater, here size is smaller. So, Tyndall effect is only shown by larger size of the colloidal sol, because in Tyndall effect, my dear students, here small energy or light is absorbed and different wavelength of light is emitted. A definite wavelength of light is absorbed and different wavelength of light is emitted. So, my dear students, it is called a Tyndall effect. So, in Tyndall effect, you can see here hydrophobic sol, size of hydrophobic sol is greater than hydrophilic sols. So, this is the concept. So, you can go the answer B, question number 43. Now, my dear students, we can see the question number 44. Which of the following is an associated colloids? And you can go the answer B. Why? Because in soap, what is the soap, my dear students? Soap is the sodium stearate. When you can use the sodium stearate in the water, and molecular formula of sodium stearate is C17 H35 COONA. When it is dissolved in water, then we get C17 H35 COO minus charge, and in this charge, my dear students, here COO minus part is this one and tail is the C17H35. So, my dear students, in dust particle you can see here tail is dissolved in oil, this is called tail, tail is dissolved in oil, while, my dear student, this is head, this head is dissolved in water. So, my dear students, here you can see the all particles are adsorbed here and form a bigger molecule, and my dear student, it is called micelle. And this micelle is also a type of associated colloids. So, my dear students, you can see here, this is the associated colloids are formed, and when these associated colloids are formed, head on present in water and this tail is dissolved in oil. So, these are the tail dissolved in oil, and in this way this oil particle which is present in clothes are removed from the cloth. So, you can go the answer B, question number 44. This is type of colloidal particles are called associated colloid, and this associated colloid is formed by the soap and water. These are the reactions, my dear students, with concept. Now, we can go to the question number 45. The CMC of a given soap in water is 10 to the power minus 3 mole per liter. A 10 to the power minus 4 mole per liter solution of the soap in water is, because CMC, what is the CMC, my dear students? Critical micelle concentration. CMC is called critical micelle concentration. So, my dear students, here you can see the critical micelle concentration is CMC, and CMC in water is that equal to 10 to the power minus 3 mole per liter. And when less than 10 to the power minus 3 means 10 to the power minus 3 is greater than 10 to the power minus 4. So, my dear students, when 10 to the power minus 4 mole per liter is present in the solution, it means, my dear students, when 10 to the power minus 4 moles per liter present in the solution, it means it is a true solution, because 10 to the power minus 4 is a smaller than 10 to the power minus 3. So, you can see here we can form the true solutions because it's smaller. So my dear students, I hope you can see the all questions with concepts, theory and reactions. I give small techniques also, my dear students, in this crash course and in these questions. Thank you very much.